什么？几只？有啊有啊，被盗了啊，什么都会。什么比你好？哦，华为没有，就你们没有去，没有去。我去哪？那边。第一题做来不及做完，就是来不及做完，就开始做完的，就其实我是也是我是一个挺正经的，我是哪个地方，哪个地方做一个哪个地方，变成真正的那个地方。你都太长了，你是非常的严格。也是，第二种是照本子。对，然后还要创造性的大。这里面多一点，这个对不对？有比较大的，我这边这边比较难修。哦， 怎么？要教哪一个？哦，有吗？因为我说什么？也不是对仪表方面，我也可以拿一定跟保证，保证你不做。那些花，还有我是些花，那你做一根根的。哦，对，我记得我拿出来。嗯。对，那个怎么刚才练习的？书本的应该啊，对吧？然后这个你还没有做吧？这个啊，你这个只是开始2个号码罢了，它每一个啊不对，放一下拿下来2半呢，不能这样子太深呢。这个你才 test 2个嘛，对不对？后面怎样？哦，这可以，这个没有想过诶，这个好像更简单哦。我是因为没有办法，我才这样子做，你知道吗？可以，我觉得可以。有时候就是这样，对啊，太多方法又不是一件好事。对，也是。所以这个说在我们那题更简单了，try 一下。但是我能怎么这个还没有，这个还没有做到？哦，我们还没有学到，没有学到。怎么你讲我没有做到？你还没有做到，说这个你还没有修到，你还没有修到这个。哦，OK，你这个才 try 1个号码2个号码吧？我要 try 几个？你要全部都证明到每一个户口。对，要用啊。对，hello，是哦，hello，忘记带 attendance 来。hello，对，PG 啊这个。啊，没有声音，谁没有换衣服？hello，臭哎，等一下，hello，PG 哦，怎么没有声音？你们班昨天有发生什么事情吗？怎么这样少人的？没发生地震。看姐还没有回来呢。那些人，那个礼拜有放假的吗？还是没有放假？那礼拜哦，Labor Day 不是
别说了，我赶着回来啊，过两天。
？No mic, no mic, no mic, no mic, no mic。好了，no mic。No mic, no 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 mic。Hello。
Hello，
哦，有 IQ，
有一你不要。分离流位点，我知道我们分离流位点要好，还快点快给我一水，啊就是吧的，就是吧。Hello. No mic. No mic. No mic. 他们来了吗？啊，先。638。
在里面是咖啡，香港的一个机器的那个。
没有。
懂那个王炳
这里。
对，
啊，真的叫表不是？
哦，就是
表啊，
BI。我就奇怪，我
表面的表
我知道，不好意思，画画。诶，要不要认真看？我刚看到。
华语字就是画画来啊，
啊，
华语字就是画画。
多一点入画。
入画。
哎呀！
好了。哦，你这个都给我搞不见了。No mic。啊，好了。
如果你要更有水平，
对，这个那边也是迪士尼对啊。哎，这个什么？你们是去我是第二个是
现在说
老神诺的啊。我看老神诺是这样。
Hello。哦。
That's been content.
Okay, thank you very much.
共读谁啊？我觉得
Okay, good. Very good morning to everyone. Haven't seen you in a week. How's your week? Very good. This week we have 3 classes. Friday 4 to 6. Hey, is it 4 to 6? 6 to 8? Hey, what's the Friday time again? 4 to 6. I sent out a notice already. Huh? 4 to 6? Okay. Okay. So I got a good news for you. Got good news?
No, 我跟德一做白表面。
Huh? We got good news. Huh? Huh? Probably will provide a formula sheet. We should be provided, but we'll finalize again, so I'll let you know again. Yeah. Okay. Okay. So let's get started. Um. So let's recall what's the infinite series. Hey, are we ready yet? What's the infinite series? Yeah, what's the infinite series? So it's a sum of sequence of number. Okay. Up to infinity, infinite sum. Okay. So when does the infinite series converges? When does an infinite series converges? Sorry. When the partial sum converge. Okay. So what's partial sums mean? What's the definition of partial sum? Sum from 1 to sum. Okay. I put too many n here. So let's change this to I. So we look at the sequence of finite sum. Okay. So for example, you look at A1, A1 plus A2, A1 plus A2 plus A3, and so on. Okay. And if it converges, then the infinite sum series has the sum, has the limit as the sum. Okay. So let me size this. So if this sum to x, finite x, then the infinite series is just x. Okay, let's start with an example. So I'll let you warm up a bit. So what is 1 over 4 plus 1 over 16 plus 1 over 64 plus 1 over 256? What's this infinite series? Does this converge? No? Yes. Why? Converge or not? Converge to what? 0. How come can converge to 0? You don't take negative number, all are positive. How to converge to 0? Now we are looking at the sum, not looking at the individual term. Okay, we are looking at the sum, not the individual term. Okay, so you need to differentiate between sum and the sequence, right? So here is looking at the sum, not looking at the individual term. Okay, so you can see that the individual term converge to 0, but what's the sum? When you add them together, what do you get? If it converges, converge to what number? Huh? So who said 1 over 3? So how do you get it? What formula? Power n? Oh, okay. You mean this one? But this is Sn, right? Okay. Okay, so if you want to use this, what's the condition of using this formula here? Okay, so you, wait, so what kind of sequence you can use this formula? This is a partial sum of what kind of sequence? You have R here, right? So what kind of sequence you need? What's this R? What's this R? Ratio. Okay, so what kind of sequence you need? Geometric sequence, okay? Only geometric sequence you can use this. So this is n partial sum of geometric sequence, okay? Geometric sequence with the first term A and the ratio R. So is the example a geometric sequence or not? Is it a geometric sequence? What's the ratio? Huh? The ratio is 1/4. Okay, so this is a geometric sequence. So last time we learned that when R is in between 0 and 1, the infinite series converges. Okay, converge to what? Huh? Converge to what? What's the sum for infinite series of geometric sequence? What? So this partial sum, in other words, this partial sum converge to what number? Convert to what number? A over 1 minus R. We can recall the proof or not? If not, please look back the proof again. Okay, so x infinity is A over 1 minus R. So in this case, your A is 1/4, and then your R is also 1/4. Okay, which you get over 3. Good. Can follow? Okay. So last time, remember I talked about geometric sequence. You can realize that some geometry object, right? So what kind of object you can attach to this number? Okay. Another way to write this sequence is 1/2 times 2 plus 1/4 times 4 plus 1/8 times 8 plus 1/16 times 16. Okay. So last time we learned that 1 plus half plus 4 plus 8 plus 16 add up to be 1, right? I take an example of the one line, right? So you cut it half, cut it half, cut it half, keep cutting half, right? But now we getting the square, okay? Square of the half. So what can you imagine? So you can imagine that you take a square, okay? So you cut it into half on both sides, okay? So the first term is just the area, okay? Half times half. And then you can take half of the smaller square again. And then this is 1/4. And then the second term will be the area of the second square. And then you keep doing this. Okay, you keep doing this forever. Okay. So you get 1/3 of the area of a unit square. Okay. Okay. So any question on how to compute this S infinity or not? Or how to see something converge? Okay, everyone happy with this wanted answer? Qingrao got problem or not? No? Okay. Okay. So we resume the example last time. So we got two fair coin. Two fair coin. So two fair coin tossed. So let's take this setting in a Malay kampong. So I call it Ali and Abu. Malay village. Okay, Ali and Abu. Chinese got learn Malay, right? When you come to the school. Is it? Okay. Do you learn kampong or not? No, it's a village. Okay, it's a village. Okay, Ali and Abu. Okay, so Ali and Abu play a game. Okay, so whoever calls head wins. Okay, so Ali starts first. Eh, so, Ali started first. So the question is, what is the probability of Ali won? Okay. So last time we say that so there are few situations, right? So first round Ali won. Okay, I mean Ali toss head. So Ali is head. Okay. So this is the first probability. We got half here because it's a fair coin. Okay. So fair coin mean half chance head and then half chance tail. So or second round. Okay. So second round we'll start with Abu. Okay. So if Abu toss head, then this game end. Okay. So if Ali need to win, Abu need to have tail. Okay. And then third round, he toss head. Okay. So these two together, and then Ali will win. Okay. So what's the probability of these two happening together? Okay, not just these two. You need to include also include the first one. So let me draw it smaller. Okay, so for Ali to win the third round, so first, so let me reorganize this thing. So this is the first situation. This is the first situation. So let me reorganize this. So first situation, first one situation. Okay, first one situation. First win. Okay, and then second win. So maybe in the first round, Ali didn't win. So maybe we don't put round here, put toes here, maybe closer to what we discussed. Okay. So second situation is first toss, Ali is tail. Okay, so he lost. He lost, then go to Abu. So if Abu had, then Abu win. So for Ali to win, Abu need to get tail, right? So what's the possibility of getting the second situation? Huh? So you could take half, half, and half here. So you get 1/8. Okay. So if you want things to happen together, you multiply. Okay, because what? Because two uh sorry, independent, huh? Okay, independent. Three independent what? Event, huh? Okay, yeah, three independent event. Yeah. So I mean, so it is really a coincidence if two things happen together. Three things is even less probability. And then if you want more things to happen together, it's even less. So can you deduce what's the third win condition? So what's the third win condition? So what's the third win condition? Any idea? So first four rounds are tail. Okay, right? First four toss, everyone lost, and then Ali win. Okay, because we only care about Ali win now, right? Because we want to compute the probability of Ali win. Okay, which is equals to 64. Okay, 32. Okay, 32. Okay, so I think we should see some pattern here. So probability of Ali throwing head is equals to half plus 1/8 plus 1/32 and so on. Okay, so does this infinite series converges? There's only few way you learn, right? For now, you learn that geometric series converges. Is that all? I think that's all. So you can really just start from whether this is a geometric series or not. Is this a geometric series? Okay. So what's the ratio? 1/4. 1/4. Okay. And so what's the 1/4, right? 1/4 for geometric series. Okay. So infinite series of geometric sequence converges. Converge to what number? Huh? What's the formula? I mean, A over 1 minus R. So in this case, you get 6, 6, 6, 6, 2 over 3. Okay, 2 over 3. Okay. Do you realize there's some similarity of this with the example just now? Huh? What's the similarity? The ratio is 1/4. Okay. So that's another way to compute the infinite series, the sum of infinite series. So you can rewrite this sequence as 2 times, yeah, right, 2 times 1/4 plus 1/16 plus 1/64 and so on. Okay, but just now we already compute that. What is 1/4 plus 1/16 plus 1/64, which is just 2 times 1/3. Okay, so this is the second way you can use. Later we will see this. So infinite series convergent infinite series is also respect the linear property. Okay, also respect linear property. Okay, you can pull scalar out. Okay, later we'll see again. Later we'll see again. Okay, so we need to go quicker. Okay, last time we haven't looked at this example yet, so we'll start new stuff. So try show that the infinite series of the fn squared minus 1 is convergent. Okay, the question tells you already converge. Again, you just need to show why it converge. So how to show? By expressing Sn. So what is Sn? N partial sum. Okay, so Sn as a telescopic sum. Okay, so telescopic means collapsing. Okay, so later we'll see how it collapses. Okay. Telescopic means collapsing. And find its sum. Usually when it converges, right, we are interested in the sum. Yeah, usually. So what does it mean by telescopic sum here? So let's see. So how to show this converge using telescopic sum? So 1/4n squared minus 1, right? So denominator is a difference of square. So it's a difference of square. So we can factorize the difference of square into 2n plus 1 and 2n minus 1. Okay, what can we do next? Minus? What do you mean by minus? Separate, okay. So you can do the partial fraction. So you can do the partial fraction. Okay, so how do you do the partial fraction? Okay. So you want to split it, right? Okay. So since you got this equation here, okay, we can reduce this equation to 1 plus a times, 1 equals to a times 2n minus 1 plus b times 2n plus 1. Okay, so I just removed the denominator, right? Okay. So I moved the denominator across. So how to solve this? Okay, one way you can solve this is by inspection. You can use inspection. Okay, so you can inspect that you can use a equals to half and b equals to minus half. Okay. Or you can use substitution, right? What can you substitute? So how to substitute? You can substitute n equals to -1. 1/2 better, okay? So because if you get rid of one of the factor, then what you left is another factor, which you can just solve easily, right? So for example, if you sub 1/2, n equals to 1/2, what do you get? 1 minus 2, sorry, 1 equals to a times 2 times half minus 1 plus b times 2 times half. So here I put multiply plus 1. Okay, which you get what? 1 equals to a times 0 plus b times 2. Okay, so don't confuse with the half here and the half here, right? So don't confuse with a equals to half and n equals to half. Okay. Okay. Yeah. So please don't confuse with a equals to half and n equals to half. Okay. Don't confuse them. They are two different halves. Okay. One, I just test the number at a. Okay. You can see that this n terms will cancel by this combination. Okay. But by substitution, we need to find what is a and b. Okay. So we can play around with n. Okay. Maybe you can pick a different n. Maybe you pick n equals to 1. Okay. If you pick n equals to 1, you still work. It still work, right? So if n equals to 1, you get 1 equals to a times 1 plus 3 times b. Okay, but you cannot solve it yet. So you need to sub another number. Okay, so it's more troublesome in this way, but it's not it's doable. Okay, it's doable. Okay, need to do more. I say row reduction, you can understand. Can I? Okay. Yeah, you need to do more row reduction. Okay. So if you clever a bit, then you get less work. Okay. Okay. So so what's going on? So what do we have? So we managed to split our 4n squared minus 1 into a sum of two fractions. Okay, let's see how useful is this guy, right? So how useful is this? Okay, let's see how useful is this. Sorry. B is 1. Okay. So swap. Yeah, swap. Okay, swap. Great. Okay. Okay, good. So let's see. Maybe I show you how useful is this thing. So let us write out the partial sum. Okay, so let's write two things and then we compare. So why we decide to work with this partial fraction here? So let's see why we decide to work with this partial fraction, okay? So let us compare these two. Okay, we compare these two. They are equal, right? Okay, so why we prefer one than the other? We already show that they are equal. So let's see why we prefer one than the other. So let's look at S1, okay? S1 on the left-hand side, what do we get? 1/4 times 1 minus 1. 1/3. Good. So how about on the right-hand side? Minus 1/. Cannot compute. 3 times 2, 6, right? And then 1/2 times 1/2, right? 1/2. Okay, good. Okay, 1/2. Okay. So is it equal or not on x1? Minus 1/6 plus half equals to 1/3. Yes, right. Okay. So you might think, The left hand side only one third, right hand side so many things. Okay, let's see more. Let's see more. Okay. How about the x2? 1/3 plus what? 1 over 15. Okay, I believe you. So how about on the right hand side? So minus 1 over 6 plus 1 over 2 plus what? Or minus what? Minus 1 over 10. 10 plus 1 over 6. Okay, you see, 1 over 6 pop out again. Okay, 1 over 6 pop out again. But 1 is minus, 1 is plus. So they cancel. Okay, let's see more. Let's see more. Okay, let's see one more. Maybe you can see the phenomenon here. So what is S3? 1/3 plus 1/15 plus 1 over 35. Okay, and then here we have 1 over 6 plus 1 over 2 minus 1 over 10 plus 1 over 6 minus what? 3. Uh, 14. 14 plus, my guess is 1 over 10. 1 over 10. Okay. So what can you see? So let us switch this order here, right? Okay, let's switch this order. Maybe easier to see. Okay, so we switch the plus and the minus order. Yeah, max is like this one. So let's switch this order here. Okay, let's switch this order. So we swap. Okay, what can you see? You can see that all the middle term cancel. Okay, what you left is the first positive term and the last negative term. Okay, and the term in between cancel. Okay, so you don't need to deal with this big sum anymore. What you left with is the first term and the last term. Okay, in the partial sum. Okay, so how does this help? Okay, so how does this help? So from here, okay, we can deduce what is Sn. Okay, what's the formula of Sn? So the formula of Sn is n. Wait, yeah. Okay, so let's rename this. I don't want n because I already used n as my indexes. So let's use m partial sum. Okay, so let's sum n equals to 1 to m of 1 over 4n squared minus 1, which is equal to the sum of the partial, sum of two partial what? Fraction, right? 2n plus 1 minus 1. And then minus 1 over 2 times 2n plus 1. Okay, so what's the formula we get just now? We left with the first term and the positive first term and the negative last term. Okay, so what's that formula? So what do you get? 1 over 2 minus 1 over 2 times 2m plus 1. Okay, so this is the formula, right? Okay, so we got a formula for m partial sum. Okay, this is what? This is a C E D sequence. Okay, sequence, right? Okay, one n, you got one number, right? So this is a sequence. Give you one m, you give me one number. Okay, this is a sequence. Series, we need to sum up everything. But now we just look at a sequence here. Okay, so partial sum form a sequence. Okay, so this is form a sequence. Okay, so if this sequence converges, then infinite series converges. Okay, this is the definition. So does this sequence converges or not? Yes. How to see? So calculate. Okay, so calculate. How to calculate? So let's write it simpler. Okay, maybe no need. Okay, let's write it simpler. Okay. So I'll ask you the question. So is this a convergent sequence or not? Why? Why converge? Why does this converge? So you can see that this is a mix of few sequence here. Okay. So you have a constant sequence here, half constant sequence 1, and then this 1 over 2m plus 1. Okay. So 1 over 2m plus 1 converge or not? So what's the limit to infinity of 1 over 2m plus 1? 0. Is this 0? Yeah. Okay. So this is 0. Okay. So this is kind of similar to 1 over m go to 0. Similar. Okay. So how to compute this big stuff here? So you need to use the property of limit of convergent sequence. So maybe I move it up. Okay. So I converge to half times 1 minus limit of n infinity of 1 over 2m plus 1. Okay. Not that I don't put limit in front of this number because limit of a constant sequence is just the number itself, the constant itself. Okay. So what we get is half times 1 minus 0, which is equals to, okay. So since the partial sum converge to half, get the infinite sum s infinity. Okay, I don't want to call it f infinity, so let's keep the s infinity for the sum of infinity of geometry series. So we write down the formula for the series, which is 1 over 4n squared minus 1 is equals to half. Okay. Okay. So this is a trick. So if you can split your term in your sequence into plus minus term, then they might cancel each other. So we call this a telescopic sum. So the middle terms collapse. Okay, let's do a little bit more, then we will take a break. Okay. Okay, so next is a test for divergence. So this is the second tool you use. Okay. If an, if the sum, infinite sum converges, okay, then the limit of n infinity to an converge to 0. First of all, think first, this makes sense or not? Okay. So if you want to sum a bunch of infinite number, right? Okay, you want to sum all of them, and then to get a finite number. Okay. If every term don't converge to 0, Okay. So for example, let's look at an example, right? So 1 plus 1 plus 1 plus 1 plus 1. What do you get? Huh? You get diverges. Okay, so this diverges. Right? Right? Because Sn is what? Sn is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you take limit of this sequence, what do you get? Infinity. Okay, so this diverges. Right? So you can see that if the limit of Fan, okay, is not 0, then the infinite series diverges. Then the infinite series. Okay. So what have I shown you here? So actually, this is a logical equivalence. Maybe you haven't learned it yet. Okay. So you haven't learned this yet. I need to tell you also. Okay, you just need to absorb first. Okay. So let's write the first as a P and Q. So if P, then Q. Okay. So what is the yellow line is not Q and not P. Okay. So here we get if not Q, then not P. Okay. So these two are equivalent. Okay. Okay. So why I show you this example here. So I want you to remember that if the infinite series converges, then the limit of the terms go to 0. If the limit of the term don't go to 0, then your infinite series diverges. Okay, I want you to remember this. Okay, these two lines. Okay, if you want to know further why this is true, we can discuss, but not for now. But now I want you to remember this fact. Is if the infinite series converges, okay, limit of your sequence must go to 0. Okay, if the limit of the sequence don't go to 0, then remember this example. This will diverges. Okay. Okay. Okay, let's take a break first, then we'll come back for example. 902 will come back. Okay, so we take a break now. So I got an outside class fact here. So actually this number, this sum, right? This sum, right? Can sum to a sum. Can sum to a non-positive thing. Negative part. But not in this course. Yeah. Not in this course. This sum to a negative part. This has something to do with quantum physics. Yeah.
它的结论是不是就是就是体现不等于，然后这个等于，然后这个如果说它这个发散是不是这个也说明这个不等于，就是
不一定。等一下我们会看到这个例子。所以它只有一个方向，它没有两个方向。它只有一个方向。等一下我们会看到这个例子。等一下会看到这个例子。
可以。然后那个 quiz 忘成绩是什么时候？
希望这周应该改得出来吧。应该改得出来。
然后就直接你把那个卷子发给我们。
我会给你们看一下，讨论一下，如果有什么分数再改一下咯。
分数你就是直接把那个卷子发给我们。
对，会给你们看，然后我们会讨论一下，然后有什么问题的话，我们就再改。
我去了。
但是班上的椅子越来越靠近这边了。另外一个班也是这样，黏住了根本了。啊，第一排跟那个讲台黏住了。哎，反方向，要反方向，要反方向，要记住这个反方向。Not P 和 Not Q 跟 P 和 Q 的关系。Not P implies Q 跟 Not P implies Not Q 没有关系，没有关系。比如说你肚子饿，你去吃东西，对不对？跟你肚子不饿，你不去吃东西是没有关系这两句话，所以人家是骗你的。然后他没有去，因为他没有去吃东西，他可以有很多原因。如果他不去吃东西，肯定他是不饿。
可能他不想跟你吃，他想要吃。
没有，假设第一句话要对一才可以。这个 description 里面会写。我啊？那写了快。你是一颗就知道高过来了吗？
要下摆它。
有动作用。哪一个？哪一个？看你做什么 project 老师看你做什么 project。
你知道哪个地方？我想写一个
你
二写一个二。
你们好多人就要搞这种编那种理论，
也是在那里会，
所以要有一个概念编那种。我这个完。说电脑也是有很多安全开关，你知道为什么吗？他们有解释，因为啊，他们的工作有分解释，但是问题是电脑这个新的东西是不多，因为你要找进追求那个东西，不一定能写的。啊。我又能带好。因为就是抽，不是
一个要拿的。
我热是吗？Oh, you right. So this one, I put on the arrow here. So arrow meaning if I hit M probability, so meaning I hit the limit, then this number.
我也讲一不得 arrow right。
Yeah, I got 10 on.
因为这个东西不是一点啊，是这个我有没有意见的？是你自己意见。我这里讲没有，因为我算到9分16分9分，你的公司也有意见。算了，我在做台。画两画。
他的选择。
我也有这个，那个原来我就你会哪一点呢？那个风格来，因为像不是那个风格那种，下面这样就真的不会了。这个风格没有。
When M goes to
没有，这个风格是一个
you. Yeah. This is by definition. So if this one converges, then the infinite sum convert is equal to this number. This is definition. This is definition. So how to compute this? You need to look at S1, S2, S3, okay, and then this one converts to X. Then this equals we see that this converts to X, which is half, then this thing is this is one definition.
So you will get all of this will get 1 over.
Converge, yeah.
Is that the correct? Yeah.
Definition, yeah, definition. Yeah, definition. Yeah. So how you compute this thing, you need to look at the sequence.
Yeah, all the things.
Yeah, until. Yeah. So if this one converges, then this one is equal to that.
It's just
你的特别对，特特。
Yeah, sequence 的话，
不要往下。
一个是看前面哈。现在我们有两个东西，一个是叫做 sequence， 一个叫做 series。sequence 是我们看这个数字的变化嘛，但是 series 我们是看这个 C 等于什么，全部东西加起来等于什么。这个我们要猜什么是 AN， 一个是猜 AN， 一个是猜这个加起来等于什么。
这个是这个，
这个是我们把两个概念组合在一起。假设说我们要算这个3的时候，我们怎么办呢？ OK， 它这个的意思就是说，如果这个东西是 finite， then 你如果把它放在 sequence 看的话，这个 sequence 要去到0，对不对？你一定要越来越小嘛。如果你越来越大，你全部东西加起来，你觉得哦，对不对 ？make sense 吗？现在？
应该 make sense。
应该 make sense。再想一想看这个例子嘛。啊，你懂什么？
就是因为它是一个 number， 如果一个 number 加一个 number， 它一直是 diverse， 它是
不一定，一直加一个 number 不一定 diverse。如果这样的话，就没有一个 converge 的 infinite series。它一定要够大，足够大。which means 就是你 sequence 的的那个你的 sequence which means 不行，不可以 which means 回去一下，再回去一下。所以我刚才是说，如果啦，再回去一次。 OK， 如果我 series converge 就是等于一个 finite sum， 我加起来是 finite sum， 对不对？这样里面的东西一定要越来越小，对不对？小到我一直加，它也是在那里，对吧？
它讲它为什么一定要是0呢？
它 converge 是0，它不等于0，这个概念你一定要知道。它不一定等于0，它是 converge 0，它可以很小。还记得那个我们上次讲嘛？它可以很靠近0，但是它不一定是0。你一定要记住这个概念，这个 converge 跟等于这个概念是不同的。它不一定是0。
如果我们 list 出来的话，它就是好像500、400、300，然后还100，一直这样子，刚刚这样子啦。我们一直在一个小方向。可以。就是它是我们可以 prove 到这样子的话，它就是 converge。wise 它就是 diverge， 这样讲。
你可以这样想象，但是如果你去不够快、不够小的话，你还是会 diverge。
小了，就我们
没有教。你这个问题很好，但是这一堂课没有做到这么仔细。你可以看，等一下再看多一点例子。有些问题不是你可以问先，但是这堂课不一定有解它，因为这个只是基本的东西吧。 对，你可以把这些问题 keep 住，但是你不要让这些问题困扰你。你先听先啊，你这些问题你可以记下来。OK，因为有些问题哦，你问的是很对的，但是它这里不够这些东西来做这些东西，所以呀OK， 但是你不要让那些问题困扰你。Hello，let's come back. Let's come back. All right, let's come back. So so let's see how we use this, right? Okay. So let's see how we use this. Okay, let's see how we use this. So for example, so let's see, for example, does this converge or not? Okay, okay. Actually, another thing I want to tell you about this is P and then Q stuff. Okay. So if P then Q, right? What does if P then Q mean? If P happen, then Q must happen. Okay. But it doesn't say that if Q happen, P must happen, right? Okay. So if P then Q, you cannot use Q to check P. Okay. You can only use P to check Q. Okay. So meaning what? Meaning if the infinite series converges, only then the limit of the AN converge to 0. Okay. Yeah. Okay. Okay. So the question is this converge or not? So do you know whether this converge or not? You don't know. Okay, so you don't know. So know how? Find the limit. Okay, so you find the limit. If the limit converge to 0, does this infinite series converge or not? No. Just now I already say. I just now already say. If P then Q cannot use Q to check P. Okay. So only when you know P is true, then Q is true. Okay. So you want to use if P then Q, you need to check P. Okay. If P is Q, then Q is Q is true. Yeah. So why we still need to check limit here? So the only thing that makes sense to do is if not Q, then not P. Okay. If the limit is not 0, then the series must converge. Okay. This is the only thing you can do now. Okay. Otherwise, you need to use other method. Okay. If you want to use this method here, you need to use this. Okay. Okay. So let's check whether this limit of AN converge to. Yeah. So that's why you see this name here is not test for convergence. This test is test for divergence. Okay. Right. Okay. So maybe you confused, right? So why we write it this way? Okay. So why we write in the first way? So first way look nicer, I think, compared to the second one. Because you have not 0 again and then diverge again. So many negative things. Too negative. Okay. We need to be positive a bit. Okay. So let's see what's the limit of our AN here. Still can compute the limit of sequence or not? How to compute limit of sequence? You can divide by 1 over n square. N square enough or not? Enough. Cube. Maybe cube better. Okay. You get 3 plus 2 over n. Okay, so does this converge to what? To 0. 1 over 3. Yeah, so don't be careless, don't be careless. So by property of limit of convergent sequence again. Okay. So the numerator converges to 1, denominator converges to 3 plus 0. So 1 over 3 plus limit of n. Okay. So I don't write this limit again on these two, right? Because they are just number constant sequence. So you get 1 over 3. So 1 over 3 is not 0. Okay. So you get not Q. Okay. If you get not Q, you can deduce not P. So it diverges. Okay. Okay. So by test of divergence, the infinite series converges. The infinite series converges. Sorry, diverges. Okay, so this few concept keep floating around here. Okay, so you need to differentiate between series and sequence. Okay, so sometimes we use sequence to determine series. Sometimes series for sequence. So you need to differentiate these two ideas here. Okay, when we talk about sequence, when we talk about series. Okay. Okay. So let's see more example. So next example I'm going to show you is why we don't have the other direction. Okay, why we don't have the other direction. Why we cannot say that when the limit an go to 0, the sum converges. Okay, because we have one counterexample where the terms converge to 0, but the sum doesn't converge to 0. Okay, so this is the famous example you should learn. This is for the harmonic series. Okay, so what is harmonic series? It is just sum of 1 over n equals to 1 plus half plus third plus fourth plus fifth plus sixth and then so on. Okay, so these are harmonic because these are the wavelength of the tone overtone. Okay, 1 plus half, 1 plus half, maybe like this, and then something like this, and so on. Okay, so you can see that this limit of 1 over n is what? Limit of 1 over n is 0. Okay, but I'm going to show you that, but the sum of this thing is not 0. It's not converge. Okay, doesn't converge, so diverge. Okay, although you can see that every term you add, right, is getting smaller, getting smaller, getting smaller, getting smaller. But it seems that it is not small enough. Okay, so let's see what happened. Okay, let's see what happened. So I think this is known to Euler. So Euler already showed it. So what can you do? Okay, what can you do? So let's write down this infinite sum again. And so on. Maybe we write more. 6 over 8. Save space, I write something important. So 1 over 9, 8, 16. Okay. So what can you do? Okay, so we can group by 2 terms, and then group by 1 term first, and then 2 terms, and then group by 4 term, and then 8 term, and then so on, and then keep increasing. So let me write down what I'm doing. So here got 1 term, here got 2 terms, here got 4 terms, here got 8 terms, and then you can keep doing. So what can I do? Okay, so you can see that this number here is really greater. Can I say equal? Maybe I can say equal. So greater equal. Can I say equal? Cannot. I want strictly greater. So 1 plus half plus. Okay, so here got 1/3 and 1/4. Why I group them like this? Because I want to replace 1/3 by 1/4. 1/3 is strictly greater than 1/4, right? Okay. And then next 5, 6, 7, 8. Okay, so I want to do something interesting. So I just replace the rest with 1/8. So if you want, let me write out these just 4 terms, so I'll write it out. Okay, and then for the 8th term, you can see the pattern. I will replace with 1/16. Okay, so what am I really doing here? Okay, what am I really doing here? So what we really get is 1 plus half plus 2/4 plus 4/8 plus 8/16. Okay, maybe you can keep going on where you get 16/32 and then keep going. Okay, keep going. So what's this? So what's this? These are 1 plus half plus half plus half plus half plus half, and then keep going on. Okay. So this is similar to 1 plus 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 1. So this thing diverge. Okay, so it is greater than something that is diverging. Okay, so which is divergent. Okay. So you are greater than something that diverges, so you also make sense. Okay. So the harmonic series is divergent. Okay, so let me write up. So the harmonic series 1/n is strictly greater than 1 plus half plus half plus half plus half plus go. Okay. Okay. So the right hand side diverges. So you are greater than something infinity. So you are still infinity. Okay. Okay. Hey, don't busy copying. Listen to what I say. Whether what I say is correct. Okay. Can we proceed? We proceed. Proceed. Okay. So next, so this is the property of convergent series. Okay, I show you in class just now an example, right? We can pull out the scalar and then use the converge sum. So let's say this is similar to the property of convergent sequence. Okay, now we have convergent series. Let's say both of them converge. Okay, and then you have a scalar. So if you want to find the new the sum of the new sequence here, you just take out the sum multiplied by the old sum. Okay. If you consider the new sequence where you add or minus addition of sequence, and then you want to find out the infinite sum, what do? You just split out the sum. Okay. Use the all sum. You can use all sum to find new sum. Okay. So find new sum using all. Okay. So there's one key part here. So if the original sum diverges, okay, and the scalar is non-zero, then the new sum where you multiply constant by the sequence you also diverges. Why C cannot be 0? What happens if C is 0? Then you just get sequence of 0. So sum of 0 is 0. So which is convergent. Okay. Okay, so let's play around with this. Have we done the example yet? Okay, so I think we did. Okay, so see, so let's apply the theorem here. So the theorem say you can use old sum to find the new sum. Okay. So this, what is this? This is an addition of two sequence. Okay, addition of two sequence here, right? Okay. How about these two sequence conversion? Only converge you can split it. So does this converge? 1/4 n squared minus 1. Do you recall this? We recall this, right? So what's the sum here? Just now we get 1/2. So what method we use for this one? Partial fraction, telescopic sum. Okay, telescopic sum. Okay, partial fraction is not enough because you still need to cancel the middle term, right? Partial fraction you just split out, but you really need the plus minus going on. How about the second part here? Does this converge or not? Why? Why this converge? Geometric sequence. Okay, good. So this is a geometric sequence. Okay. So what geometric sequence is this? What is the ratio? 1/3. Okay, the ratio is 1/3. Okay, good, very good. So this one converge because of geometric sum due to geometric sequence. First one converge due to telescoping sum. I just keep it here first. So also diminishing Sn. Okay. So they all converge. Okay, good, very good. So they all converge. So we can find the new sum using the all sum. So how do we split out this sum? So how do we split out the sum? So this is the addition of two sequence, so an and bn. Okay, so we can split an and bn linearly. Okay, linearly. Since you already learned, so let us use linearly. Okay. And then we can split further, right? Okay, we can split further. Okay, here is a Cn. Here is a constant. Call it, okay, maybe call it Dn. I call constant C. Right? So I can further split linearly. Okay. So when can I split the sum? When can I split the sum? What's the condition of the theorem? Only when the series converges. Okay. So since we know that these all converges, we can split them. So what's the number we get? So we get half plus minus 5 times, we haven't computed this. So what's the sum of infinity of this? Huh? What? 1/2 ah? 1/2? 1/2 ah? I believe for you. 1/2 ah? I also have 1/2, okay. So, okay. So I get -2. Okay. Ah? Okay, so you haven't do exercise for long, right? So I let you do this exercise. Determine whether this converge or diverge. I give you 3 minutes. You try. But yeah, can't check out. Okay, let's check whether this diverge or converge. Let's just recall what have you learned. Geometric series converge. Okay, if it is geometric series, when the ratio is between 0 and 1. And then test for divergent, right? So if the limit is not, limit of sequence is not 0, then the difference series diverges. You also learned that harmonic series diverges. Okay. And then you also learn the linear property of convergent series. How does this all work? It's okay, you don't work it out, but I want you to think first. Try hard. This is like you are in the exam, right? Your exam, you also will hit the wall, right? So I let you hit the wall first. The difference between exam and now is I can give you answer now. I cannot give you answer in the exam. Okay, almost 3 minutes. Any idea or not? Any guess, any idea? Diverge? You guess diverge? Anyone guess converge or not? So why diverge? Only one sound. So why diverge? Diverges. Okay. Okay, good. And so how you compare this diverge series with 1/3n? Series of 1/3n. C, huh? Okay, so you said your C is 1/3, which is not 0. Okay. Just now, what did we say? So what did we say about property of a divergent convergent series? So if an sum of our an diverges, okay, and C is not 0, then what? Then the new sequence C times an also diverges. Okay, good. So we are going to use this. So because we got the first condition diverge due to harmonic series, second condition C is not 1/3, then this must happen. Okay. Then by theorem, the sum of n equals to 1 to infinity, 1/3 and diverges. Okay. Okay. Don't just copy. Listen to what I say. Check if I say correctly or not. Yeah. Okay. Any question? So you can see that. What can you see again? 1/3n. What's the limit of this sequence? 1/3n. Also equal to 0, but the infinite series doesn't converge. Okay. Yeah. Although every term getting smaller and smaller, but when you add them up, they're not necessarily converge. Make sense? Okay. So I write here, although limit of n. So you need to be careful. Okay. I need to be careful. Okay. So next, so here says that there's a remark here. So a finite number of terms does not affect the convergence or divergence of a series. So this is similar to sequence. Okay. If you throw away the finite term at the first, it doesn't affect the limit of your sequence. So for instance, suppose that we are able to show that for the series n over n cubed plus 1 is converged, then sorry, you can see so I need to highlight this part here. So you can see that these two, one of them is starting at 4, the other is starting at 1. Okay. If you can show that the one that's starting at 4 converges, starting at 1 also converge. Okay. Because you just take the sum and then add the first few. Okay. The other direction is easier, right? If you can show that n equals to 1 to infinity converges, you throw away first few terms, you also converge. Okay, so the other direction is more obvious, but another the other direction, yeah, but this direction is also true. Okay, so both way is true. So these are true both way. Okay, does it make sense? Repeat. Okay, repeat again. So I repeat again. So I repeat again. So I repeat again. So okay, so you can see that these two, okay, one of them you start at n equal to 4, one of them you start at n equal to 1. Okay, let's say you show that the one that start with n equal to 4 converges. Okay, then it also implies that n equals to 1 converges as well, right? Because if the first series starting at 4 converge to x, what happened to the series that starting at 1? You just add the first few terms to x. Okay. So you just add a1, a2, a3 to x. So this is still a finite number. Okay. So my another claim is if it converges for n equals to 1, and then you throw away first few terms, of course it also converges. So this means these two directions are equivalent. They are two direction equivalent. These two directions are equivalent. Okay. So if the infinite series converges, you can throw away finitely many terms. Okay, okay. Is it okay? Before we go to the next new part. Okay, so this chapter, right? You will keep learning new tools only. Then the hard part is how to put all these two together to help you. Okay, so we just keep learning new tools. Okay, so this is about property of convergence. Okay, next. So next we will use integral tests. Okay, so meaning this have to do with integral. So how are we going to use integral test here? So let's say we want to study this. Okay, study this infinite series. So can you guess whether this converge or diverge? Converge. Okay, you guess converge. Okay, so you can see that the limit of an also going to 0. Okay, so we need to see whether this go to 0 fast enough or not. Okay, whether it's fast enough or not. How to think about this? Let me see. Okay, so how can you think about this? Okay, how can you think about this? So you can, one way to think about this, this is the box. Okay, it's a box, unique. Cannot say unique box. Huh? Okay, so box with mm, width 1 and height 1/n. Okay, so you can imagine this. So you can imagine this is a box with 1 and then 1 height. Okay, I'm lying here, right? 1 times 1 is a square. So here. And then you can think of the next one as a box with width 1 and half height, and then so on. Okay. 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 By the argument. Okay. So next. So what we do is we want to place this on the XY plane. Place this on the we place this on the XY plane. Okay. So we place this on the XY plane. Okay, we place this on the XY plane. Haha. So I think, am I doing stupid stuff again? Let me see. Oh, my height is wrong. So my height should be squared. Okay, that's all. Okay. Okay. So what's the benefit of doing this? Okay, what's the benefit of doing this? Okay. So we already have this square here. Okay. And then we can plot 1/x squared, right? Okay. So what's the relation between y equals to 1/x squared and this area stuff, right? Okay. Really, you can place all these boxes under this line here. Okay. Do you want to check why is it true? Okay. For example, x equals to 1. Okay. Y is equals to 1. Okay. X equals to 2. Y equals to 1/4. Okay. So this graph will be touching the one of the corner of our box. Okay. And then keep the area of the other box under this graph here. Okay. Make sense? Okay. This only work for this example. Later we will see the general statement. Okay. So if you know how to solve area under the graph, right? Area under the graph. Okay. So if area under the graph is finite, then these boxes are also finite, right? Because area under the graph have more things than the boxes. Okay. Yeah. Okay. So let's see. Okay, let's see. So let's integrate 1 to infinity of 1/x squared dx. Okay. So what's this? Okay, so we only compute here. Okay, so we start from here, go to infinity. Go to infinity. Let's go to infinity. Okay. So how to compute this? So this is an improper integral. So you need to do some limit trick first before you do it. Doesn't really matter, but calculate doesn't really matter, but formally you need to do this. Okay, so what's this integral here? this integral? Huh? 1. 1. So this is a finite one. Do you see a bug here? No, no one see the bug. Huh? What? Guan Tian say what? Guan Tian say what? So does anyone see where's the bug? Anyone see where's the bug? What have we computed? We only computed integral from 1 to infinity. How many boxes we cover? First, I cannot say you are wrong. But calculate t number of boxes. T minus 1. Yeah. So we left out these boxes here. Okay. So we left out these boxes here. Right? Because the area from 1 to infinity only cover boxes from 2 up to infinity. Okay. So what we can really deduce here is for n equals to 2 to infinity over 1 over n squared is less than the integral from 1 to infinity 1 over x squared dx, which is 1. Okay. So we show that this sum here is less than 1. Okay. Of course, this sum also bounded below, right? Bounded below by 0. Okay. So this sum is in between 0 and 1. Okay. But what's the question? The question 1 starting from 1. Okay. You only know about starting from 2. So how to work it out? What? So you want the sum starting from 1. How to relate to this starting from 2? What's the difference of adding from 1 and adding from 2? What's the difference? Just the first term. Okay, the first term. So what's the first term here? First term is 1. Okay. So you can see that our original series is less than 1 plus 1, which is 2. Okay. So this series that converges. Do you know why we cannot integrate from 0? It didn't, first of all, it didn't reach 0. It didn't reach 0. But let's say we want to, no. Okay, first of all, it doesn't reach 0. What happens if you integrate from 0? Huh? You get infinity. So the area keep increasing. Okay, so the area keep increasing. So it's not useful if you integrate from 0. Okay. 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 Sure. Next. Okay, I will show you that this 2 here, right, is a double-sided. Okay, you can show something converge. You also can show something diverge. Okay, this is a double-sided 2. Okay, so it's like a knife. Okay, you can use knives to cut veggie. You also can use knife to kill people. Okay, so this is a 2-sided. So now, how about we reduce the power of n, right? So instead of looking at square, look at half. We look at half of it. So this sequence here also converge to 0, right? Okay. So does the series converge or not? No. Because I forgot to bring the attendance sheet, right? So you write down your name and write down your ID, name and ID, and then write out number. Number also 1, 2, 3. Okay. Number, name, and then ID. Okay. Number, name, ID. Okay. Okay. So so we also think of this as a box. Okay. So we think of this as box as well. So now your height is 1 over square root n, and then your width is 1. Okay. You can think of the box again. Okay. Think of this box. Right. So what happened here? So if you put the box on xy plane again, and then you consider the continuous function of y equals to 1 over square root n. Okay. Instead of placing this square on the other side, right? You can place on top of this curve. You can place on top of this curve. You can try yourself if it is possible to place it the other way or not. Okay. You can place it above it. Okay. Can you imagine you do it? Okay, let me draw it. One, two, three, 4. Okay, so maybe you can place it this way, right? Here is 1, and then yeah, left, right. So left and right of the endpoint. So here is other corner. No. You see. This box here, okay. You also can put it here, right? So you can shift your box to the left by 1. I think it doesn't work if you do it this way. You can try out, okay? But I don't want to discuss about it for now. Okay, so let's say you can see that. Let's say we place the box, you see, well above our curve. Okay. So can anyone guess what we want to do? Area under the graph and the area of the box. You want to deduce converge or diverge. Okay. Can anyone guess what thing we're trying to do here? So if the area I get is very big, diverge, then something bigger than me also diverge. Okay, so this is the strategy. Okay, so we want to try whether this strategy work or not. So how many? Okay, so later we'll do it. So okay, so how to compute integral from 1 to infinity? So 1 to infinity is where? So let's check out this domain here. So 1 to infinity. Okay, maybe going down is okay. So let's go down. Hey, I noticed someone didn't come. Please don't sign for the person. I want to track down the person. Don't play with me, okay? I track down is I deal with that person. Please don't interfere, okay? Yeah, I want to check who didn't come. No matter how I will see that person in the quiz, but don't sign for your friend, okay? Don't sign for your friend, okay? I will deal with that person myself. Okay. Okay. Yeah. Okay. If not, yeah. Okay. I want to track down the person. Okay. Hey, anyone computed this integral? Infinity. Okay, so you get infinity. So since the boxes, okay, the boxes is the sum here is greater than the area of the boxes are greater than the integral area under the curve. So the series diverges. In particular, I know one from your group didn't come today. Sorry. Okay. Okay, good, very good. Don't sign for that person. Very good. Don't sign. Hey, please don't play around with me. Okay. Don't force me do something else. Okay. Yeah. So, I mean, lecture, right? Lecture is between me and you, individual. Okay. Okay, I choose to believe you this time. If you cheat me again, I will do something else. Okay. I can count. So easy. If the total number doesn't tally, then doesn't tally lah. Right? Okay. Cannot. Okay. Yeah. Okay. So what you need to take note here? So what do you need to take note here? So you need to take note here we are dealing with continuous function. Okay. Just now we find convergence or divergence using sequence. Okay. Now is function. Okay. So you need to differentiate these concept here. Okay. So what's the yeah. Okay. Is it okay? Huh? Okay. Okay, so what's the upshot here? So let f be continuous, positive, and decreasing. Okay, so what do we have just now? The function. First of all is continuous. Second of all is positive. Okay, so you don't like go around the x-axis, go up and down. So continuous, positive, and decreasing. Okay, decreasing. Okay, the function decrease. Okay, if increase, you can, of course, the area diverge. Right. So only decreasing will make sense. Okay. So three item here: continuous, positive, and decreasing. Okay. And then suppose your an is equals to fn for the positive integer. Okay. Then the inference series converges if and only if the improper integral converges. Okay. So you can see that this one here, right? This n equals to 1 here, and the integrate from 1 here doesn't really matter. Okay, as long as the boxes tally with the area under the graph, that's fine. Okay, no matter where you start, because first few finite terms doesn't affect the convergence. Make sense? So this n equals to 1, starting from n equals to 1, and integrate from x equals to 1. doesn't really doesn't have to follow that n must be equal to 1. Okay, you can start n equals to 4, 5, any place as long as it is under the it is everything under the graph or above the graph for the area. Does that make sense? For example, okay, we give an example. For example, just now here, right? We start the series with 2. Okay. As long as you make sure that everything for convergent, every boxes is below the graph. Okay, for convergent. For divergent, you need to make sure every box to infinity is above the graph. Okay, for divergent. Okay, for convergent, you need to make sure the infinitely many box is under the curve. Okay, for divergent, you need to make sure the infinitely many boxes is above the graph. Okay. Okay. Either you less than something finite or you greater than something infinite. Right? Okay. If you are greater than something finite, doesn't say anything, right? Infinity also greater than finite. Something finite, yeah. Okay. Take a break. Okay, I'll take a break. Okay.
你这样速度来得及吗？到变成之前会很赶吗？
我慢咩？
不慢，我都是后期咯，因为我不想赶。
我还
不想赶。
我们还有1个星期是吗
？1个星期不了，现在有这样少。
还有2个星期。5个星期。
我觉得
等一下哦。
先交完这个星期一下，就知道下个星期能不能起。
哎，走到11:05吧哈。
啊？
到11:05吧。
然后？
哦，我看课本领多，
对不对？
是呢？
问你啊。
问你哦。你出啊？
不是 ，I mean，
我不是你出好啊，你出。
不是，什么课本有什么我都不知道。
本到11:11的 subjection。
这个是什么？
考到哪里？
考到这一课。
这一课啊？
好的。这一课考多少？11:5。
好玩啊？可能咩？我不信每个老师都教到这样准哦。
考这一课。考这一课。
那个没有跟你讲考哪里没？
有。
没有，你要
有，我会跟你们讲，我
不是讲考哪里没有考是最重要，不是讲考哪里。
给点hints。
哪里没有考？
这个礼拜会给。
哪里啊？
哪里没有考
？2个礼拜啊？
这礼拜会给。
对的，还有2个礼拜吧。
没有考一帮我们在浪费时间。
叫他这样，他叫我，你叫什么名？佳明哈。
我只要考试啊。
上次你考 quiz 是不是坐在这一排？啊，坐那边，这样是他。你叫什么名？方舟哈。你那天考 quiz 是坐在那边。你坐那边对不对？旁边那个同学叫什么？不是他，另外一个戴眼镜的。汉子汤 ，OK， 可以。
什么？
没有在。在哪里？他在哪里？他在哪？怎么可能？我认得他。快点叫他来啊！赶紧叫他来。我下个小时要看到他。没事，你叫他来，我管他去哪里。下个小时他出现在那里，我才算他。这个是2个 service 吗？然后这个它是那个什么 converge， 然后这个是 converge， 但是如果我这个是 converge 过后，可以知道它是 converge。 哦，
它是有大于它的，这肯定是大于它的，这能不能真的？就跟那个
没有啊，你如果减的话是小吧，小于
所以说它总体大。
啊，对对对，OK OK 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 可以可以 OK 可以可以，也
如果它，我就真的它是 Convergent 的，能不能证出它是 Convergent？
可以
可以这样子的。
可以，
那我反
但
过来
是正这
可以吗？
难道我 skip 了东西？我 skip 东西了？
刚刚问了，
你等一下啊，对，等一下会教的，等一下会教的，要这个
哦
是今天，应该可能要下一堂。
哦有，
有，
那应该后面那个是一样的，就那个 Diverge，应该是一样的。
如果
这个
大
这个是对，这个是 Diverge，这个哦。
Yeah, can you explain a bit more about the inverter? That's how we do. We know is it
这个是
converts or diversion
如果真的这个是
using the interpreters.
using the integrated circuit. Oh, okay. So,
So you only give the main idea, right? So for about the draw, the box must be above if diverts. But for converts, the box must be below.
Yeah,
如果我
that's right.
证明还是
And then how about the test, the interpreter test?
It's the same thing. It's what we discussed. It is exactly what we discussed. So you need to make sure. You need to make sure. How to say? You need to make sure. You need to measure the height of the box.
如果它是大过的话，我就可以
Okay, you need to. 对，
应该是应该要考吗？这个
考，
这个方法要考，
考，全部都有考的。
其实考试。
You see for example, you see for example, you see for example,
不是
you see for example,
，midterm 不是
you see for example.
你要毕业啊？
How to say to you? Let me think. 他说 ，Okay, you need to compute these two things. Okay.
Yeah.
So how to compute these two things? So you need to measure A1. You need to measure A1 is equal to F1. Right? A1 is equal to F1. And then A1 equals to F1. Then if this integral converge or diverge, then this sum converge or diverge. So where does start, right? Where does start really depend on
This one. So if econ is divert, so one is must be divert also.
Second.
If this one is divert, so the other one must be divert.
Diverge, yeah. Because this is a if and only if, so you can say that this diverge, then this diverge. This converge, this converge. This converge, this converge.
电子咩？电子咩？
可以 if and only if 是可以来去自如的。Maybe I repeat again. Okay.
if then 才不可以。
对 if then. Yeah. I repeat again. If not clear, you ask again.
所以你改了。
有没有改好？
那个面的主点呢？
那个小要足够小要足够小，跟大足够大，其实就是1 over n， 还有1 over n square 吧。
也不一定，我不知道。那还有中间呢？
中间，考试不要出中间。
没有考 I mean 是 I mean
可是中间它
这个的 scope 不是。
其实我在想一个东西哦。
在想一个。
1 over n 最后是 infinity 嘛？1 over n 就是1 over infinity equals 1 over 0。 对不对？Which means like
你不可以这样讲，不可以这样讲，你不可以讲等于，我们是讲 limit 罢了，是 approximately。
这很大力耶。
哎，这样子的话，只是加最后我是加
也要
人家
跟你讲，
以前的 pro 就是这样大家
不是零，不可以靠近，不是等于零，靠近零 approximately 可以。
个零，但其实
那老师有没有玩 Angry Bird？
上面是因为我的东西这样子走，走到一个
没有啦，
地方
哪里有？
，approximately，比如讲0.00，
很大，可是很
那你应该要这样想嘛，你有这个导致吗？
哎，这么你没有做的？
一定要这样想。
没有做，刚刚没有做
因，为还有减嘛，还有
刚刚有做嘛？好，我 next series
有
啊，没有听课啊，没有听课抓到。
那个
什么在讲？
没有睡觉，
没有啊，高到
为什么
是零啊，
这么为啥？
靠近零。
那为什么不可以讲用保的来讲它是保的0.0？
可以啊，可以用，可以用。
那如果它是保的0.0的话，它不是看 convergent 零诶？
可以啊，
对，
你要讲吗？sequence 是 conversion 零啊，series 就不一定了。series 加上去啊，sequence 是越来越少，越来越少，但是它还是一个正数啊 ，positive number， 你还是要加。啊，你在想一个问号。对，我开始了，我开始了。
有一直打我，欺负我。
OK。
有看 NBA 吗？还有对
NBA。OK。Okay, I want to repeat this integral test again. So just now we go through all those stuff, right? Okay, so we go through all those stuff. If you don't know, okay, so what you need to do is, as long as you can make sure that A1 equals to F1, A2 equals to F2, A3 equals to F3. So meaning you take your sequence, okay, realize as a function. And here is 1 over n. You realize as function. Okay. Realize as function. Okay. This statement is if and only if. Okay. If and only if means these two are equivalent. So if the sum converge, the integral converge. If the integral converge, the sum converge. If the sum diverge, the integral diverge. If the integral diverge, the sum diverge. So any direction works, okay? Because this is a if and only if, okay? So these two are really the same thing. But because we don't know how to solve the infinite series, but we can do the integration, okay? So we just use the integration to solve it. Make sense or not? Does it make sense? Okay, so because this part seems hard, okay, sometimes here seems easier. Okay, so really depends sometimes, but yeah. Okay. So who knows, you want to integrate something hard, but it is easier here. Not sure, but for now, you will usually see that here is hard, and then the integration part is easier. Okay. Okay, so next part. So let's keep with this example. 1 over n squared plus 1. Okay, so this conversion. Okay. So we can use integral tests here. Okay. Or maybe, okay, for this example, maybe you can use other method. Okay, but now let's use integral tests. Okay. So to test integral test, f has to be continuous, positive, and decreasing. Okay. 1 to infinity. Okay, you need to check 3 things. Okay. So first of all, is this continuous or not? Okay. So what is f actually? What is f? What function we want to take in this case? S squared plus 1. Okay. So why is this continuous? Is this continuous? Okay. So continuous. Why? Because it is a composite of continuous function. So S squared is continuous. So S squared plus 1 is also continuous. 1 over continuous function is still continuous away from the point where the denominator is equal to 0, but you won't get x such that x squared plus 1 equals 0. No x in R such that x squared. Okay, and it is in a particular is continuous from 1 to infinity. Okay, we just need 1 to infinity. We don't need everything. We don't need everything. Okay. Positive, is this positive? Positive. Okay. So 1 over n squared, sorry, x squared is greater than 0 for 1 to infinity. Okay. Decreasing or not? How to show decreasing? Smaller. How about more systematic one? What? Differentiation. Okay, you check that the derivative is less than 0. Okay, so what's the derivative? Minus 2x over s squared plus 1 squared. So many x here. So is this less than 0? Why? So, hey, be careful, negative sign. Because our domain is positive. Okay, the denominator is square, so it's everything positive here. So the only part will become negative is here. Okay, but you are still infinity 1 to infinity, so this is less than 0 for x in 1 to infinity. So this one I also need to put x in. Okay. So this satisfy this integral test condition. So to check about the series, we just need to check the integral. Okay, see whether this integral converge or diverge. So what's this integral? Still, you need to do the improper integral. Okay, so what's this? We don't want to skip this integral, so we get tangent inverse. If you are interested, you can try at home. Okay, so what's next? Okay, so what you get is, where is the place that tangent go to infinity? 90 degree, huh? Okay, so pi over 2 minus pi over 4, which is pi over 4. Okay, so that means this integral converges. Okay, this integral converges. So by integral test, the series converge. So here is n is convergent. Okay. Hey, don't keep copying. You just see whether it's okay. Huh? Okay. Which part you want to see?
is the convergent.
Okay. Okay, next. Okay, so we'll do this. So let's consider any p. Okay, just now we look at square, we look at half. Okay, how about any p here? So what happened to this series? Okay, we study a infinite family of this series. We call it a p series. Okay, 1 over n to the power p. So now we will show that this power series, okay, not power series, p series is convergent if and only if p is strictly greater than 1. Okay, strictly greater than 1, only this series converge. Yeah. Kiro, do you see this? Okay. Okay, so how do we show this? So this is an if and only if, right? So if and only if mean two direction. Okay. If P series converge, then P greater than 1. If P greater than 1, then P series converge. Okay. So let's do one direction first. Okay. So let's do one direction. So we suppose B P greater than 1 first. And then we want to show that P series converge. Okay. So we want to use integral test. So integral test, what to do? What three things you need to check first? Continuous. Yeah. 哪个箭头? Oh, this direction here meaning, okay, if and only if meaning we got two direction here. Okay. So P if and only if Q. Okay, two direction. Okay. So if P series is convergent, then P is greater than 1. If P greater than 1, then P series is convergent. So two direction. Okay, so going forward and going backward. Okay, so we will do the backward first. Okay, so let's say we want to do the backward. Backward mean we assume P greater than 1, then we want to show the series converge. Okay, so to show series converge, we want to use integral test. We want to use integral test. So there are three things to check: continuous, positive, and decreasing. Okay, so what function we want to take? What's the function we're taking? 1 over, no n now, x to the power p. Okay, so on what range, what domain, sorry, what domain? 1 to infinity, good, very good. Infinity. Okay, so is this continuous or not? Continuous, right? Okay, 1 over sp is continuous from 1 to infinity because we don't care about the 0 point. Okay, so that one already throw away. Okay, is this positive? Right, you take positive power of positive number, still positive. 1 over positive number, still positive. So this one I write only discontinuous when p less than no, p greater than equal to 1 and x 0 equals 3. Okay, so decreasing, how to check decreasing? Differentiate. Okay, you look at the first derivative where you get minus p over x to the p plus 1. Okay, so when is this less than 0? Okay, so this thing need to be less than 0. Okay, so what happened here is it's already greater than 1. Okay, so here is positive. So bottom is also positive. So negative or positive by positive, you get negative. Okay. So I write here since p greater than 1 and n. Okay. So we can do integral test now. So let's compute the integral from 1 to infinity of 1 over xp dx equals to what? X to minus p plus 1 over minus p plus 1 p1. Okay, so you can do the integral and then plug in the value, which is just 1 over p minus 1, which is convergent. Okay, so by integral test 1 to infinity of x to the power p converges imply the sum converge. How about the other direction? How about the other direction? Let's get rid of this. Hey, you just call out if you don't understand anything, okay? Daniel, is it Daniel? Daniel, yeah. You just call it out. Yeah, because maybe someone else also don't know. You just call out only. You got question for this one? Do you have questions for this one? No. If you have any question, you just call out. Got question? Yeah. Okay. Just call out. Okay. So how about the other direction? Okay. So the other direction is what? If P convergent, then P must be greater than 1. Okay. So instead of doing that, right? So we will assume, so now we want to prove P implies Q. Let me bring big. P implies Q. Okay. So this is equals to not Q implies not P. Okay. So we'll assume another way, like what we did for test for invergent, divergent just now. So we assume P is less than or equal to 1, then the series diverge. Is that okay? Okay, I use contra positive now. So this is called the contra positive. Because this is easier, so I'll use this. Okay, so P less than equals to 1, right? There are few cases. Okay, there are few cases. So it can be equals to 1. First case is equal to 1. Second case is in between 0 and 1. Okay. And then third case is less than 0, yes. Equal to 0 first. Okay. And then less than 0. Okay, we break into a few cases. Equals to 1. What happens equals to 1? What's this? 1 over P. 1 over N, sorry. What is this? Diverge. Why? Because it is a harmonic series. It is harmonic. Okay. In between 0 and 1, what happened? So in between 0 and 1, we can use this integral test again. Okay. So integral test says that if it is what? If it is diverge. If the integral diverge, then the original series diverge. So does this integral diverge or not? One to infinity over x dx. Okay, so does this diverge? Diverge or not? Why? It's the same limit, but now we change our p already. Okay, we change our p, which is less than 1 and greater than 0. Okay, what happened to this term here? This term is just some positive number. Okay, nothing interesting here. How about this power here? Power will be negative. Okay, so negative, so this term become positive. Okay, so you take t go to infinity, you get infinity. This one. Okay. If I want to say, I say SP minus 1 is less than 0. Okay, so by integral test, the original series diverge. Okay. So you can see that these cases are we use different way to prove it. Okay, so it's like refreshing your mind. So what happened when power is equal to 0? What do you get? What do you get? 1. Sum of 1 to infinity. Converge or diverge? Why diverge? You need to give the test, give a test. How to test this? Test for divergence. Okay, because the limit of your an is not 0. Okay, it's equals to 1, which is not 0. Okay, or I put 1 here. So this implies that the sum over n0 diverges. Okay, how about next one? Next one. So 1 over n to the power p, which is greater than 0. What's this? Why diverge? We want to say diverge, right? What is this? This is really n to the power modulus p. Right? Okay. So 1 to the power p, 2 to the power p, 3 to the power p, 4 to the power p. Infinity. Why? What test you can use? Test for divergence again. Okay. So test for divergence is very convenient. As long as you know that your term is not converging to 0, then you straight away deduce that. Deduce what? The series is divergent. Okay. If the sequence converges to 0, you cannot deduce that whether the series converges. Okay. It is not 0. So if you want to add something that's non-zero, keep going on, then the sum diverge. Okay. Okay. Okay, keep going. Okay. So I left the next one as homework. So this one is homework. Also use integral test. I will tell you the hint. So just use integral test, but how to use it, you try. Okay. Ln n over n. Why start from 4? Why start from 4? Huh? Oh, okay. Why start from 4?
不是，我们讲的不一样。
Okay. Ln n over n. Yeah. Left is onward. So there's something to see here. Where does this turn positive? Okay. Where continuous? Where decreasing? Okay. When? Yeah. Okay. I mean, this question, this ln over n question, okay, you need to be careful when it is positive, decreasing, and continuous. Okay, so next part. So next part, if the inference series an converges and has a sum, we can approximate x using xn with the error given by the remainder x minus xn. Correct? So if your sum is always greater than your partial sum, right? Because you keep adding number until you reach x. Okay. So when you take x minus the partial sum, you get a positive number. We call Rn. Yeah. So if you can imagine that when this n grow, Rn become smaller, right? Because when you add more and more terms, you are approaching your x, approaching your limit. Okay, so Rn will get smaller. So how to estimate this Rn? So it turns out that, okay, using integral test, you can find the bound of this Rn. Okay, so this Rn is bounded by the integral from n plus 1 to infinity and bounded above by integral from n to infinity. So why is it n plus 1 on the right side, n on the left side? Why not the other way around? Huh? So what? So n plus 1 is happening later than n. Okay, so you integrate from n has more area than the n plus 1. Okay, so next. So for example, how to do this? So let's say we want to find an upper bound for the error. So the top is called upper bound, the lower one is called lower bound. Okay, upper bound, bounded above, bounded below. So find an upper bound for the error in using the sum of the first 10 term to approximate the sum of the convergent series 1 over n cubed. So it says that, okay, what does this say? So this series converge, okay, converge to a number x. I don't know what is x yet, okay, converge to a number x. Then it says that I want to compute x10, okay. So what's the difference between x and x10? Okay. If you want to compute the exact number, what do? You need to compute x and also x10, and then you take the difference. But now we just need a upper bound, okay? It is bounded by some number. So what number is this? So this is the difference between the remainder after you're taking x10. And then you want to bound it above by 10 to infinity. Okay, bounded above by n to infinity, bounded below by n plus 1 to infinity. Okay, so this asks for upper bound, so we'll bound like this, which is equal to what? So this integral is 1 over 2x squared 10 to t, okay, which is what? So you notice that we are doing quite a lot of improper integral here because we deal with infinity. Okay. So this term is 0.05. Okay, so what does this mean? So if you compute x10, okay, how far is it from the real number, the real sum? Okay, it is 0.05 at most. Okay, so this is your error. Okay, 0.05. Uh, any question? Any question? Okay. Okay. So next question is how large must n be so that the partial sum xn approximate the sum series with error no more than 0.005. Okay. So you want the partial sum get close to your actual sum no more than 0.005. Right? Okay. So you need to add more term so that you are get closer to your final sum. Right? So this means what? This means you want to bound your Rn by 0.0005. Okay. You want to bound your Rn by 0.0005. Okay. But to do this, you can bound the upper bound of your Rn. Okay. So if you make sure the upper bound of your Rn is less than 0.005, then you can make sure your remainder also less than 0.005. Okay. So this is a question just solving what is n. So what's n? So just now we saw that this is 2n squared. Okay. So we need to just to make sure this is less than 0.005. Okay, so if you check this out, you will get n greater equal to 31.623, something like that. Okay. So you need to take how many terms? N equals to, you need to sum up until which term? 32. Okay. We need 32 terms to make sure the error is not sure the error is no more than 0.0005. Okay. Okay. Your question? Keep continue. Got question? Huh? Wait. Got question or not? Okay. Question? 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 Anything? Okay. Okay, so what's next? So what do we get just now? We get Rn. Okay. Let me make this bigger. Okay, just now we got Rn bounded above and below, bounded below by integral from n+1 fx dx, bounded above by integral n to infinity fx dx. Okay, so we can modify this inequality, right? Instead of bounding the remainder, we also can make it a bound on our sum. Okay, our final sum. Okay, you can see that if I add xn to all of these inequality, we will get that the final sum, okay, is bounded by the partial sum plus the integral part. So how to apply this? So use this above inequality with n equals to 10 to estimate this sum here. So we want to estimate this sum. Okay, this question already assumed that this series converge. Okay, converge to what number? We don't know. Okay, we don't know. So how? So we just want to estimate it. Okay, estimate it using n equals to 10. Okay, so what's x equal to 10? So it's just a1 plus a2 plus a3 plus dot 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 plus a10. Okay. So I think we won't go through this calculation here. I just write out the step. If you want, you can compute yourself. So A1 up to A10, you just use calculator. You can do it. Okay. So from above, you can see that the final sum here is squish. Okay, squeeze. So not squish. Squeeze between S10 plus integration from 11 to infinity, and then bounded above by x10 plus integration of 10 to infinity x3 dx. Okay, the two number you will get is around 1.201664, 1.202532. Okay, so you can see that this number is squeezed between these two decimal numbers. Yeah. So you can imagine if I take more, for example, x100, x1000, x5000, okay? You can see that these two numbers will get closer and closer and closer, okay? Oh. Closer and closer, okay? So you can estimate your value better. Okay. Okay. So next, I think we will stop at this test for today. Let's see how much we can go. So next is the comparison test. I'm not sure why this called direct. So maybe just call it a direct comparison test. Okay. So one key things here is when you use direct comparison test, right, you need to make sure all of them are positive. Okay. A bit like the squeeze thing. Okay, squeeze theorem. Okay, you squeeze your an in between bn and the constant sequence 0. Okay, so if you got this squeeze, what happened? If bn converges, okay, so I think we should draw some diagram. Okay, so here is 0. Okay, and then maybe you got some B, and then you got A. A is squeezed between these two. Okay. So you can see that if B converge, then A also converge. Okay. Converge, I mean, is the sum converge. Right? It's really the sum converge. If A diverge, okay, if AN diverge, okay, I mean sum of AN diverge, then sum of BN also diverge. So this is a bit like the discrete version of the integral test, okay? Because integral test, we look at the area under the graph, but now we just look at the individual height. Okay. So if you want to prove this, right, you should use the monotone sequence. But I don't think we want to do it here. We don't prove this. Let's see how to use it. Okay, so how to use this? So determine whether this series converge or diverge. Okay, we want to use this. Okay, so how to use this? Let's reduce to something we know. Okay, what do we know? We need to compare series, right? So what kind of series we know already? We know P series. Okay. This infinite series converges if P is greater than 1. Diverges if P is less than or equal to 1. And geometry series. Okay. So which one is closer to this series here? P series or geometric series? P series, huh? Okay. So what kind of P series we want to compare to? What kind of P series we want to compare to? Okay. P series, if the power is positive, then it converge. Okay. So if you want something to converge and then show that this converge, right? The only choice is you need to make the B first. Okay. Right. You want to bound this series by B or the sequence by B. Okay. So what kind of sequence you can bound it? Yeah. Oh, that's good. Is this enough to bound? Why? Okay, so what's this? What's this? Okay, what's the 4n plus 3 part? This part is always positive. Okay, because our n is going from 1, 2, 3, 4, 5, 6, 7. So your denominator is greater. Okay, meaning your fraction is smaller. Okay, denominator greater, fraction smaller. Right. So if m greater than n, then 1 over m is less than 1 over n. Yeah. 3 greater than 2, 1 over 3 less than 1 over 2. Okay. Okay, so what's this? So what's the series of 5 over 2n squared? Okay, what's this? So by the property of convergent series, right? We know that 1 over n squared converges. Okay, so why this converges? 1 over n squared as a p series with p equals to 2, okay, which is greater than 1. Okay, and then also with and scalar 5 over 2. Okay. So in this case, by the direct comparison test, the sum of 5 over 2n squared plus 4n plus 3 converges. Okay. Next question, determine whether this series converge or not. Do you want to guess first? We won't do this, we will left as exercise, but do you have any first guess? Converge. Converge. Diverge? Why diverge? So if it is diverging, you need to compare to something diverge. Okay, greater than something diverge. If you want to show convergent, you need to less than something that converge. Less than something that the series converge. You can compare with n 1 over n. Okay, so it's greater or equal to 1 over n. Yeah. Yeah, you can start from there. Okay. Before we leave, I seriously want to deal with this attendance stuff. Okay. You can apply leave from me if you want. Okay. For example, you say this time maybe I a bit tired or I headache. Okay. So I will give you go a few times. If you in the street you headache, then you got problem. Either you need to go and see doctor, either you need to change. Okay. You see me, he headache, huh? Come and talk to me. Yeah. Come and talk to me. Yeah. Tell your friend, come and talk to me. What? Your friends come already? Where is it? Where? I can't see. Okay. Go to what? 他去厕所 ，OK。不可以每次去厕所啊。Okay, please give me back my attendance. Yeah.
这应该是大于的，n 方很多。
M 方，可是 M 方你不能够做你要做的比例。如果你大于一个 converge 的东西的话，那你就做不到。对，如果你要大于一个东西，就代表你要让它 diverge。如果你要 converge，你就要小于一个东西。对，它也小，它应该也是大。
是。对。
呀，我的纸为什么没有人还给我？我看你
小逼在这个。所以你要不要做一个 summary 啊？
什么 summary？
这个够多 test。
会。
做一个 summary。
会。
要感觉我们一起做了。
会。你帮我找我的 attendance 一起来一个。帮我找一下。这边。OK， 谢谢。来。拜拜。没有去吃饭了。
我去 LY4，所以啊。
LY 哈，这里帮你塞一点。有塞。你说可以啊。LY 可以啊。
如果他从人家一开始不是在这里开始，现在他整个家环移过来样子。
我就是这样。刚才我一开始不是说你可以看左也可以看右吗 ？Depend on 你要看什么你可以看左，可以看右。拜拜。你几时来了？
我刚来了。
没有，你没有打招呼一下，我不知道你来。不好意思。我以为你不来了。
就是讲，如果你要 prove convergent，你就用这个要 prove divergent。
对，没有错，两个都可以用。所以那个 theorem 就是说 ，as long as 你 start from 1就可以了。而且就算它前